Hello. In this video, we want to explore the music dataset from the correlation perspective. Simply, we want to know that if there are correlations between the input variables of a dataset. Um, we are working on Jupyter Notebook. The first cell that you can see, we are importing the libraries that we want. I import pandas to work with data frames. I work with Seaborn for visualization, right? And then I want to read the data set that I have, which is um, a music data set, and I run this command, and then I want to explore the data set that I have, how many columns we have here. We can see that we have ID, title, artist, and those kind of things. We want to explore the data set to see what columns we have, and here it is. So we have a music data set, we have ID, title, artist, information, top genre, year, and all the other columns for a single song, right? And obviously, when we are talking about correlation, we are talking about numerical data, right? So we can see that there are possible, let's say, columns that we want to find a correlation between them. Those ones that are numbers. Basically, the year can be considered a number, but for our data set, as you know, it can be considered as non-nominal, so it's not kind of numeric column to find the correlations. And there is a simple command in Python that you can find all the correlations in one data set using CORR or correlation, and it considers automatically the numerical columns, and it considers year as well. If we want to find correlation for specific columns, we can select the columns we want. For example, if I want to find the correlation between the energy and danceability, we can just select those columns, right, and find the correlation between them. But usually you can do that for your data set by just using the data frame, and Python automatically recognizes those columns that are numerical, uh, and they are numeric and contains numerical values. And here you can see that there is a number for each cell. So obviously we don't we are not looking into the same column correlations, right, because it's obviously one, but we are looking into some columns like BPM, energy, danceability, and those kind of fields that we are looking for. And as you can see, this is not a best visualization that we can find correlations between the columns. um, Now, one of the things that we can do is using heat map, right, to visualize the high correlated variables in a graph or in a chart, right? And if we want to visualize the correlation between two columns graphically, like I said, we can use a scatter plot. A scatter plot is a very good visualization that shows the correlation between two variables. Um, for example, using the Seaborn library, we can use a scatter plot function. The data that we have, we are looking for data sets that the the dance value is greater than 0. We are not interested in those ones because we want to exclude the outliers. But any case, if I remove this part, it means that I want to consider the whole data set, right? So data equals to the name of data set that I am using, and those columns that I want to see the correlations, right? X is speech, the other one is pop. So I want to see that if there is any correlation between two variables or not. And I run this command, and I should be able to see the correlation. And as you can see, here we have a value 0, 0. That's why I excluded that the previous time. So if we want to exclude it again, we can use this comment. So it simply says that from music filter the music just for those records that we have dance value greater than zeros, right? In bracket, we write down um, music dance greater than zero, right? And those columns that we have, and after that we have a better visualization than before, so we are not looking at zero value or negative value at this point. And we can change the columns if we want to, um, if we want to find a correlation between different columns as well. uh, Sometimes you want to know that if there are correlations between the variables visually. For this case, if we want to see several variables correlation at the same time, we can use a scatter plot matrix. All right. And so a pair plot is one of the visualization that we can use. Here by selected the data frame, we are looking for dance greater than zero, or you can add other conditions here. And when we have our selected data set, then we can just restrict our data set to those columns that we want to see the relationship, right? And it shows kind of in a scatter plot matrix the correlation between different variables. So I would say dance and energy here we have high correlations, right? So because we can see in this part the distribution of data is more than others, so then the data are not scattered across the coordinates, right? So we can see that this is a positive correlation, while we can see kind of negative correlation um, in other coordinates, right? And for some others, we don't have enough evidence regarding relationship. For example, this variable like host and the dB, we can see that the points are scattered across the coordinates. So this cannot be kind of let's say um, a correlation between two variables. So it doesn't say specifically the calculation or estimation of correlation between two variables, but generally a scatter plot matrix gives you an idea that which two variables potentially have correlations, right? So then you can just concentrate on those. For example, from here I see that dance and energy, they have direct correlations. I can come back here to this graph just to those variables. Another one was, I think, energy, and we can see, yeah, here we have a correlation, and then we can use, for example, linear correlation relation algorithm or other relation algorithm to find the percentage and the strength of relationship between two variables. Another visualization that we can use to identify the relationship between the columns um, is parallel coordinates. In pandas, there is a parallel coordinates in plotting package that you can visualize columns on different axes. We have one axis for each column, and there is a line that connects different columns to each other based on the records that we have. So they are basically connected through records, and in this way, we can identify the patterns if exist in the data set. And apart from those columns, we can add another column to show the grouping of the records if there is any grouping, right? For example, here we are using dense, BPM, dB, and energy for columns of music dataset, and we add years. So we wanted to see these four columns based on year, right? So we in the argument we specify the columns, and after that we add the grouping column.